I guess we can start doing some live coding. Let's see, start with, okay, so the topic for today that we have is bugs, errors, and regular expressions. So that's why we have the code for today. If debugging is the process of removing bugs, software bugs, then programming must be the process of putting them. Okay? Let's see. Let me set up first my environment. TSC demo.ts. Node. Oh, okay. No. For the first examples that we would have, I'll show you just JavaScript. Because the textbook, the TypeScript already created a lot of mechanisms so that you won't have those problems, but we'll show you anyway. Okay, let's first start with strict mode. Why are we using strict mode? Basically, it removes the flexibility, which is the ambiguity, so that's what we want. So developers know when we're checking a different code, they know that, hey, this is how your code works. Hey, this is the number that you want, okay? Also, in strict mode, errors are reported. So we can start first with having a file with without the strict. Say, let's create a function, and in that function, let's call it, can you spot the problem? Okay. And in that function, let's say we have a for loop with initialize a variable and another, the loop evaluation, see 10, and the loop counter. Inside the loop, you can just say console.log, happy, happy, joy, joy, joy. And then we'll invoke that function to run it. Let's see, node. We can just see this. Yeah. So I can either show you the console down here or the right side, they're the same. So can you spot the error though? Let me put this bigger. It works in JavaScript, but can you spot the error? Should be, it would print out 10 times. Yep, happy, happy, joy, joy. And that's from, I think, Ren and Stimpy, which is a very disturbing cartoon. Super disturbing. Okay, let's see if we use the use strict. And again, with JavaScript, it doesn't really tell us what's wrong. But if we run that JS file, now you get an error. So again, we said with use strict, you will get errors instead of nothing. Okay, and he's right. In JavaScript, without the use strict, you can use variables. I mean, declare variables without using the keywords var, const, and let. So if you look at this in TypeScript, don't need to run it, but we can just put it here. It will already highlight what's missing. Cannot find name counter. And if you put let, that should fix it. Okay, that's the power of TypeScript. Another way is, we talked about using the this. So let's say function person, and it has a parameter name. And inside of that function, we have this.name, which basically means person.name, and assign whatever was passed there as the new person.name. Okay, let's say let name is Ferdinand, and person Ferdinand. So in this line, what we're saying is we created a variable named Ferdinand, and we want to pass Ferdinand string to a function named person. Okay, let's try to console.log and use date Ferdinand, I think, or the name. No, let's see the name. Let's see. We still have Ferdinand. What seems to be the error? Again, JavaScript doesn't really help you with what's wrong. See a while ago, did it show you? So just going back a while ago when we executed the JavaScript file, and when we used the useString keyword, it gave us an error and it shows us where it is. Okay. This time around, the error is not using a new keyword. So let's say we do the useString. There you go. Doesn't know, it cannot set property name of undefined. So if we put new, that should work. Does not. I think this should be Ferdinand. Sorry, Ferdinand. There you go. Without this one in useString, that should be an error. Okay, cool. So let's go back to TypeScript and just paste the code. Let's see if it would help us. Let's do some type annotation. Let's just put any for now. Type annotation. Okay, never mind. But again, TypeScript, once you pass this type safe, it would already say that it needs a new keyword. Okay. I'd like to move on and let's say another one. Correct news with new keyword. Example 2. We're still going to be in JavaScript though. Let's say we have a variable x, and look, it's fine. The output is 600. But if you use useString, that shouldn't let us. To fix that, you just need to put the variable let or const. Again, in useString, you can put that inside of each function, which is overkill. So people just usually put it in the scope of the file. So at the very first line of your file, just put useString. Okay. You can also declare delete. Yes, and you can also delete a variable. You don't need to do. Also, let's go with functions. So let's say create a function add P1, P2, and nothing for now. P1 and P1. And it still runs, no errors. Right? Let's try to use useString. Then we get errors. It would say, we'll underline this one, and it would say duplicate parameter name not allowed in this context. Okay. Next is writing to a get only property. So if you remember getters and setters, when you have getters, you just retrieve a value and you should not do anything on it. But if we try to do this in JavaScript without the strict mode though, it would allow us to return 0, close that, and then let's try to modify this one to, let's say, 300. There you go, no errors. But again, if you put useString, it would complain. Cannot set property of x of object, which has only a getter. Okay. So basically, that's the use of useStrict, and also we talked about this before with comparisons. So without the useStrict, you can compare booleans with just if you want a strict comparison, you would use a triple equals, right? But if you put this useStrict at the top, you can use the double equal sign, and it will still simulate these strict equals. Okay, let's move on with types. Types, we already done so much in TypeScript. So we'll just show you how other developers might use JavaScript and type annotations. So let's say you have function, say, tell a joke. And in that function, you have a saying. And inside of that function, you would return the saying, the parameter, plus a string, haha, haha. Okay? And then developers usually put an annotation by just putting a comment above it. Let's say, okay, the saying is a string, and then it would output a string. It would do something like that. Great. Okay? We can move on with types because TypeScript already deals a lot of things with types. Next is we're going to talk about tests. Why do we do tests? We do tests so that helps us find mistakes, but not only that. Because if we try to do console.log all the time, it could be very tedious, time-consuming. So that's why we have tests, or also they're called as test suites. So with tests, you can create a test suite that just runs all the tests that you want. Instead of checking every time, hey, is this equals to this? Is 1 + 1 equals to 2? Oh, how about this? Is 2 + 2 equals to 4? But if we have a structured way of putting a test suite, and then we just run that test file, you can easily check all if they pass, fail, pass, fail. Okay? So in tests, we also have what we call unit tests. And again, what I talk about, it's an automated process of testing, let's say your functions, and they're usually performed in an IDE, integrated development environment, or you can also use them in your VS Code. Okay? Why is it important? Because it's one of the earliest testing efforts performed on the code, and the earlier defects are detected, the easier they are to fix. So if we have a timeline, if we fix the code earlier, that just costs us less. But if we, let's say, come production and you get errors and you have to fix them, that is way too costly. So that's why we want to do some unit tests and some bunch of other tests such as user acceptance, things like that, and integration testing. So we'll talk more about unit testing. It's also very helpful when you're doing your coding challenges. Instead of like checking one by one, you can have this structured way. So in unit tests, we do have a good pattern, and it's called AAA. It's arrange, act, and assert. Okay? This is just a sequence. So in arrange, what you do is you prepare everything for your test. Let's say I'm expecting this kind of value. I'm expecting this kind of variable. Let me create an instance of this object first. Act basically just means is running that thing you want to test. Okay? When you run that function and your let's say the output is 2, now you go with the assert. The expected here, that's the actual here. Let's say I assert them to be equals or not. Okay? So instead of giving you another library to do some unit testing, I'll show you how to create a unit test from scratch. Okay? Let's first create a function. I think we can go back to TypeScript now. Let's do this one plus ESC demo JS watch. Okay, let's start with a function. Let's say we have a function with the name, we want to add 2 elements in the array. And inside of that function, we again have the open parentheses, and we define the function parameter. And the function parameter name is R. And what do we want as our parameter? We want the type to be a number of arrays. And what do you want the return to be? You want the sum of 2 elements, hence we want a number. In the function body though, we just want to return the index 0 plus the index 1's value and just sum them up. Okay? Next, let's create our own assertion function. So function, let's say we'll just name it assert equals. And in the parameter, we'll put expected, and it is a number, and actual, a number. And because we want to assert if they're true or false, the expected value that we want is a Boolean. Okay? So with just seeing this function, you're now seeing that, hey, the user will just put their expected number, and the other one is they would run a function to check if the numbers is the same with what we're expecting. Okay? So basically, we create an if function. If expected is equal to actual, then we just return true. If not, let's just return false. Okay, I think we just need to put this down for now. Okay, let's do the arrange, act, assert. In most unit tests, you just import a library and you don't really need to create this. Okay? So in arrange, let's say we create a variable. Let's say the expected value that we want is 2. Okay? We also arrange or prepare the parameter. Let's say the parameter is 1 and 1 in a number array. So to act on it, run a function. Let's say we create a variable named actual, and let's use the function. Add 2 elements. And let's pass the parameter. And when we do some assertion, is basically we just call the, let's just create another variable to store that Boolean value. Assert equals and expected actual. And let's just console log out that one is equal. Let's see. Can we run this first? Out. Oh, oops. Okay. What happened there? And node demo.js. Does not update. Why is that? How did my environment break? Okay, I know. ts config, let's do this. ts ts config. Sorry, because I changed some of my project settings, so it was not compiling right away. So here's the JavaScript, it looks the same. And if I refresh that here, I should see a true. Okay, let's just remove this. So again, let's start with our unit test. In arrange, we created a number variable that we assign the number to, and we prepare also the parameter we're going to pass to the function that we want a unit test. In act, we're actually using the function and put the parameter there and put whatever the value that we get from add two elements function and assign that value to actual variable. And now we want to assert if they're both equals. Basically, we created an assert equals function. If expected and actual are equal, let's return true, which we had here. Okay, we can also change this to a different one. Let's see if we can compile that manually. Can we do something like this though? Yeah, false. There you go. And I'll also simulate how we have a bunch of tests from scratch. Because what's good with unit tests, if you know this structure already, it's the same for other programming language. You just need to get the concept. Let's say we create a function, let's say print our test. And in that, let's just create a for loop. Less than, let's say the is equal dot length. Inside of that for loop, we just want to console.log. And let's say we test number 1, which is the I, or number 2. And then we also want if is equal, and then access the index. Is equal. That's weird. Should be possible. Okay, now let's just change this code a bit. Now we can show you a bunch of tests. That is equal, and then we want that as a boolean of arrays. Then initialize with nothing. And then now let's try creating our test with just this simple modification. So let's have the array, and let's call the push method. And let's say we want to assert equals of what? The add two elements. No, actually the expected first. Let's say we expect the sum to be 5 and the actual number to be, okay, let's pass the add two elements. And it should have an array, 3 plus 2. Why is it complaining? Oh, array. Why is it complaining? Once more, okay. So this is my first test. So I should have, let's say, print test. Refresh that. No, test number, let's say number 1. Test number 1 is true. So I expect the number 5. I have an array of numbers of 3 and 2, which returns a 5. So we can just copy this. Oh, again, copy this. And let's see, 1 plus 2 should be false. Okay, let's get another true value. Let's say 3. 1 plus 2 is 3. So your test 3 is true. And usually in your IDE or your editor that you have this unit test imported, like the JUnit, you would have a lot of beautiful check marks. And I can show you, I think, because I have it, but let's see. Okay, I can show you a screenshot of my previous class with the software testing instead. So, or let's see. Let's check my terminal instead. cd dev ls, let's see, cd, I think maven, ls, oh, I do have, good. Code insiders, let's see. Let's see if it has those beautiful stuff. So again, even though this is Java, you would see the, can't scroll down, okay. Arrange, act, assert. It's kind of similar, act on it and assert if they're equal or not. Let's see if I have the. Don't know where to check that again. Yeah, I'll just show you a screenshot from the document because I forgot how to open up the checks. Let's see, software testing. Let's see, assignments. Do I have it here? Okay, here. Just to have a glimpse. Go ahead. Go ask. No problem.
So, I suppose I understand the idea that methodology. However, if it comes out false, I'll just use it false. So I mean, if you did I'm not using it. You'll want a lot. So long. Trying to think the errors. So with that, if you want to find out where, one is the console level, right? The other one is the debug function. And again, this is pretty helpful if let's say you know a bunch of use cases that can make or break your program, and you should have like the expected to be the same as the actual. I know, but I'm saying if you have like that, yeah, sorry.
Oh, this one you know because you invoke the function.
I mean, I'm just thinking this, I guess, would be a good final. True or false.
Usually what happens in this one is if you didn't think about the edge cases, oh, someone input a negative one. You didn't think about that and then it breaks your program. Instead of having inside your function, hey, if users put -1, just say, I'll kick you out. No, you just say, oh, return this number instead. That means it's nothing. Okay.
I guess what I'm saying is that I can see for showing your work, showing that
yeah.
But at the end of the day, it's not going to tell you
Go ahead. Maybe you can.
I think this gets into program design. Pieces of logic to be testable. So if I assert, if I have a function that does one thing, and I write a test, I say I put an input, it breaks. That means that somewhere in the function, like this is like where it's broken, but you know what this function is supposed to be doing. So then you can break that singular little piece of code out. Like instead of having a 100 line function, it's 10 line function. Read it and understand it as it's all.
I do. I get that. I don't see the advantage of steps as much as logic.
Oh, this one is whenever, before you push code, especially in open source project, they would always ask, did you test your code? This is one of the tests in itself.
Okay, so
this is done by the developers.
So it's a production requirement, essentially.
Again, this is done by developers, not the testers. Before it was testers, but because of DevOps and those things, developers take on a lot of testing stuff as well. Okay.
I'm not good. I guess you just wait about it.
Okay, we'll continue on with the. Let's have a short break, I guess, because it's 10. I'll see you 10:15, and we still have debugging, error propagation, exception handling, and regular expressions. Sorry, I said it was short, but at least the concept is not that hard compared to OOP. Yeah. See you in 10 minutes.
I wasn't trying to give you a hard time.
No, it's good. I want you asking questions.
Because I guess I guess this way, I guess would be considered a check a block kind of thing, just a proof of concept. Yes, it works. I tested it moving forward. But if I'm just, writing the code at the beginning, I'm not going to do this. I'm just going to, do a bunch of console log or print or whatever, just like outputs in different areas, so I can figure out what's going on if it's not working the way it's wanted to.
Yeah.
But I understand what you're saying is a check the box, moving forward to production. I guess.
Word.
Amrita, just could you tell me again, because I want to write it.
What?
For next week, what they are going to learn? Because I want to prepare
Full stack. The hands-on. So basically, you can just check the next folder. That's it.
Okay, the hands-on is already there.
Yeah.
I checked it 2 days ago, and it's just for one module.
It must be somewhere else if that's the case.
CS242, right?
Yeah. CS242. Let's see. I gave you access already, right? Can you see stuff? Let's see. It should be here. Oh, one is actually, sorry, because before putting it here, we do dump it here, so it's easier to have them in one go.
Okay.
And then we deploy it to the other folder. Because before we didn't have this folder, so we are dumping everything here. At least it's 1 to 10. Okay, let's grab more.
So next week you're going to after the
Yeah, probably maybe in a week. I'm taking a few days off of it so I can catch up with it. And then I'll kind of see what their schedules are like.
It's a shame you dropped Sean McCoy.
What? Well, I have more. Yeah, I got more.
Shady got hurt.
Yeah, everybody got hurt.
Like 60 something hours.
I just destroyed my entire league. My highest scoring. Yeah.
Don't tell me you had like something to do.
What?
Something
No, Ingram. Ingram killed it. Logic did good. Samara did good.
Yeah.
Even that game.
Yeah, I'm sorry.
I don't even know
Your
what
team's on.
I don't know what happened.
What happened?
They didn't even. It's like one thing after
You know
another.
what happened? The same thing always happens. First doesn't keep going until the fucking fourth quarter.
No, but Carson dropped that ball.
And he fumbled.
Like that literally did everything. And then like
They scored on that.
we covered the center. They were kicking. Now it's first down. Like it's one thing after another.
Yeah, I didn't really watch it.
All this little stupid shit just came together to. We only lost by 6 points.
Yeah, I mean, they scored touchdown. Stop them for the most part.
Well, like until the Carson fumble return for the touchdown, they hadn't even completed the Saints had. It was gonna be. It would have been like 14. Or it would have been like 14-7.
I got Russ.
Instead it was.
fucking
Yeah, he ran 2 touchdowns in 2.
He got 41. That team has to stack with Russ.
Because I wasn't sure if I should. I was deciding whether or not to play the San Fran defense or the Seattle defense, and so I was like, well, they don't have Drew Brees. Like they got some weapons, but they don't have Drew Brees. So yeah, and so I stuck with Seattle. And the annoying thing is that it seems like it counts points even if they score on offense. Like the fumble return touchdown, the defense wasn't on the field. So but it just counts the points scored in the game, which is bullshit. Like, the fucking defense didn't even know that it was points out. So why am I getting?
Does that? That Taylor guy.
You know who cleaned up this thing? Which one they have marking?
I had to do that.
Did you? God
Cleaned
damn.
I was like, 1 touchdown, okay. 2 touchdown, okay. 3 touchdowns, jeez.
Wow.
Still go.
Yeah, I was playing something they had up there, and I was like, what in that? I never would have thought that. I thought that was more of a throwing shootout. Please don't do what I have to do.
Three and 0 in 2 weeks.
Our first place guy got taken down, and 2 of the guys who were 0-2 won. Me and someone else.
Could have been this.
About 21.
I think our whole week did a big shuffle. Because I was looking, why is that first place like why is he doing it? His points against were literally the lowest in the week. My points 4, my points 4 were like my points against were the highest, and I'm only 2. And his points against are the lowest, and I'm number 1. Like no shit.
It's like real life though.
Yep. And then of course, like this week, I scored more points than any other team in the first 2 weeks. I scored like the lowest. We're gonna.
It's not time to depend quite yet.
Things will even out. Oh no, I'm good. I'm just waiting.
I got a couple players on, but
Oh yeah.
Thank you.
about 21. I started adding on to the
Like it's 133 to 70. I think I've got it back.
Yeah. Let's go from 60.
He's got You guys are playing that, right? You got that's it. So they get a 70 points. I'll bow down. I'll stretch down.
What are the best people? I don't know what that's talking about. It's bad. You don't know the players. Brandon Cooks.
Everyone I've been picking up, I've just been on the bench because man, other people will get it.
That's why I did. I got three tight ends.
My starting is solid. To replace him, John. Yeah, it's good.
Like I also wrote this.
So next week you gotta get a defense in. San Fran's fine. That's the reason I didn't pick him up because I would have had to pick him up and then had to pick up another defense. So I just gonna roll Seattle for. You got three tight ends, two defenses.
Rank the numbers.
Yeah, what about your other position?
I'm stacked.
Injuries.
My bench consists of
Injuries. Wait for them to get injured. Someone fucking lost range in my league, so I took my waivers. The first place dude fucking snuck in and beat the waiver. I mean, he was better than like fucking I had 40 picks. Mario's fun. No, Corey Davis is a good player, but he's done literally nothing. That's the tough part. It's like, when I draft these guys, they're never getting to get the ball, but they're yeah. No, I picked up Robinson, but he was bad. Yeah, but he got the jump, but. Yeah, I'm just gonna run. I'll probably get rid of him. I'll go back, but he's just there just in case. But like stealing him too. What? Stealing was second and third.
More or less, yeah. I get it.
Oh, I got two.
Oh my god. That's how it's been for me. It's like my starting it's like the all my bench. It's like a bunch of zeros. And then you look at the guy and their bench is stacked.
That's like part you don't want. You don't want you do, but no.
I know. That's why I'm like, oh, it's fine. If it's like very obvious the guy is not going there, otherwise, I know there is. Oh, It's 20 years. I saw the years.
Oh, yeah, it just did that.
This is now.
I know.
Okay, let's restart. So now we are in the topic of debugging. So if we have bugs, we have the term debugging. It just means removing the bugs. Okay, why do you need to debug? Usually you do that as a next step once your program misbehaves or produces an error. You try to debug to figure out what the problem is. So we already done a lot of console.log, so we're not going to talk about that because basically you can just go in a function body, in a for loop, and if you're not sure of what the variable is, the value, you put console.log in the variable name. That's it. Okay? So in most IDE, you would have a debugging tool. And basically when, for example, like this one, you need to just click debug and start debugging. And nothing happens. So when you just run the debug without any pause or halt, meaning a breakpoint, it just goes over the program and that's it. But once you put a breakpoint, let's say I put breakpoint in line number 2, and I hit start debugging, now it will run the program and stop until that one. Let's zoom that in. Put this on. Okay, on your left-hand side, just focus on, you would see the variables. Again, the name, which is a string, has the Josh. Because again, if we follow this program execution, this is not yet called. This is just declaring a function. And line number 5, this was called. And now when it was called, it would go inside of the function body. And that's where we want to stop the program and check the current state. Okay, so when we stop at line number 2, Again, we have this as undefined because it does not point to somewhere. Also, the name that was passed was Josh. Okay, so global is just you have access to all the objects, so no need to worry about that. So also in most IDEs, you would see on the right-hand side, you would have the continue, and hit that, and it ends. Try that again. We also have the step over. So a step over just means that the debugger will step over a given line. If a line contains a function, the function will be executed and the result returned without debugging each line. Okay. Next is step into, just take one step, and then step out means that we return to the line where the current function was called. So basically, you can just mess around and click and go to the next one. And when I click next, it now goes to the next thing that it would do, which is return the value. Again, when we set the breakpoint, it halts in the program line number 2. And during that time, we still haven't returned anything. We're still checking, trying to concatenate. If you step into, take one more program execution, it will now do this, returns it. And as you can see on the left-hand side, you can see the return value. Hello, Josh. Okay, you can add a bunch of breakpoints, as many as you want. We can just hit restart, click that one, and restart again. Let's see. Now the first, when we restarted the debug, and because again, even though we set a breakpoint here, line number 2, we did not really invoke the function yet. That's why when we run the debugger, we do 2 breakpoints. It first halts on this one, because code line number 5 gets executed. Again, you would see this object and the prototype and the location of the files. Usually you would check this one, the hello function. You see it has the name hello. Okay. One thing to note about when you try to debug is it also goes deep to the other files like node modules or packages. Because again, even though we have a simple line of code, it is dependent to so much files. So like you have the console.js, and it's really hard to explain what these guys are doing. I guess this one is using the console.logout, so it's dependent to the console.js. Step into, and it will go there until let's try to keep clicking that. So as you can see underneath the hood, there's a lot of things happening. Okay, and basically that's how you try to debug stuff. And let's see, let's show you more. Let's see, this one. Okay, so talking about debugging, right? Let's talk about error propagation, because that one is related to debugging. Okay, let's say we create another function first. And the function is we want to find an index, and we want 2 parameters. One is an array of numbers, and one is just a number. Let's just put this as the value, okay, or element, better word. And we want to return a number. Okay, inside of that, we'll just have a for loop. Let's see, we'll do it the other way around. We'll start from the end of the array, and then I less than 0 equal to 0, less than 0, minus minus. And then inside of that, whenever we're gonna check each of the element of the array, and if we get a match of the value that we want, let's return the index, which is I. And if not, if we check all of the array and we did not see it, sorry, element, return -1 to say to this user that we haven't found it. So let's try to invoke that then. Say we have 10, 20, 30, 40, 50, and we want to find the number 20. Console.log test. Let's see. Oh, still the same. Okay, wait. And node. Oops. I can't find modules. Node this. Node. What's happening? Okay, let's see. It's my JS file. Okay, I can just run this. Okay, node. JS. Demo.js. Okay. So let's see. We have a function to find the index. We put the array, and we want to check if 20 is inside of the array. Okay, this should be this one. Oh, still wrong. Because I need to change this one. There you go. So with the function find index, it returns us the position of 20 if it finds it, and it's in the index number 1. Position number 1. Array starts at 0. Okay. However, this program is faulty. If I can give you a few seconds, we can spot the error. Right. Oh, that one I haven't heard. Greater than equal sign? No. This one, this one. Oh, okay. So in most simple programs, we denote -1 as what was it? One. Oh, it's not showing an error. It's faulty. Oh, okay, so right now the topic is error propagation. In error propagation, we do have 3 steps of having it. We should have the fault. A fault can lead to error. An error can lead to failure. Before going deeper into that, I'm just going to say that this function, it works, but it's faulty. Right. It's one. What else? Still works. What if we put number 10? Would we see it or not? Yes, and now you get a -1. So this is what we call as a faulty state. If the user asks for 50, 40, 30, and 20, we say that, it works, but it's faulty. But if the user used number 10, the faulty statement now creates an error. Okay? Let's see. So basically, we just need to change this one. 2 equals to 0. Now, if we look for 10 in the array, the index should be in position number 0. Okay, we can also use some, let's put it back there. Let's try to put the debug, let's see, here, or here. Let's see. Let's try that. Let's go to debugging mode. See, element 10. Let's see, and then, so it shows that in the local variable, we do have the array size of 5. We have 10, 20, 30, 40, 50. Okay, and the element that we want to find is number 10. Let's try if this works. So see, it skipped. It really didn't show us, actually. Maybe I should put this in the for loop. Let's try that again, reset, debug. There you go. So this one, we can now, with just the debugging tool, we can now verify I, counter. We initialize it as array.length -1. Our array length is 1, 2, 3, 4, 5, -1, which is 4. And when we started the debugging tool, it stopped at code line number 2. Our first item is number 4. And then we can try to step in, step over. See, it becomes I3. It means it finished one loop. Becomes I2. It finished another loop. Becomes I1. It finished another loop. Right now it's in the index 1 of the array. And 0. However, again, I becomes 0, but because it evaluates here in the loop condition as false, so it doesn't go inside of the for loop. It goes out right away, and hence we got the -1. Return value -1. Okay, so again, one of a good use case for debugging tools is you have a bunch of variables that usually you try to write up every loop. How many count is this now? Is it 2? Is it 3? Is it 4? And when you put debugging tools, when you run them, usually you would get the value of the variables on the other side, so you can keep track. Another example of a faulty statement. Let's see. Let's create a function count negative. So this function, what I want is I would have an array of numbers, and I would check how many of the numbers are negative. So you want to count how many of the numbers are negative, right? So first you need to initialize a variable and set that to 0 to count how many negative numbers we have, and create a for loop again. This time let's do the normal way. And then then r.length, don't need -1 there. And then I++. Let's now have the evaluation. If r is less than or equal to 0, so we count plus. If not, if we end the loop, let's return how many of the negatives are there. Let's log that out. Create cons that just to test it. Call the function. Pass an array of numbers. Let's say -1, 11, 0, -2, and let's just log out that one. So with just the line number 11, how many negative numbers are we expecting? Correct. So now he spotted it fast that line number 4, it's a faulty statement because it will also count zeros. But the function says count negative. 0 is not negative. So let's try to log that out. Oh, we still have the old one. Wait a minute. Let's see, is this one? No, it's not compiling again. Let's see. Oh, there you go. So we run the function and it counted there was 3 negative numbers, which is wrong. Okay. So just to fix that, you just need to do this. Run that again. Should be 2. Okay. So let's move on to the topic of exception handling. And if more questions, it did return the count. So again, the function count negative would return a number, a data type. And as you can see in the return keyword, beside this is count. And what is count? It's actually a number. Mm-hmm. Okay. Uh-huh. So let's just do some simple example with exception handling. But before that, exception handling is important because it is easier for the end users to use your code and to use it correctly. If you don't handle errors, your programs may crash, lose all your customers' work, and likely you don't know where the bug occurred. So there's 2 things about it. One is you definitely use exception handling to have an error that's more informative, meaning instead of just saying error at line 1, you can say, oh, error because your variable is not a number, something like that. Okay. The other one is it's a nice aid for debugging. Again, when you're checking stuff, you throw an error, and it would say that you can also use that error. Let's say you can pass it to someone in the IT that says, oh, you're logging this some error that's related to, let's say, the infrastructure, right? Or you can pass it to the help desk when there's like technical support. Okay. Okay, let's just show some code. Just gonna paste this for now. It's a very short code. Let's see. Okay, this one. Let's go back to JavaScript again. So we have keywords that are also common with other programming languages in exception handling. So you have the try keyword. Basically, it's a statement that lets you test a code block. You have the catch keyword that basically lets you handle the error if you get an error. And throw statement lets you throw a custom error. Okay, let's try to run that. Oops. Something bad happened. Let's try to put that here. Ooh, never mind. What's happening? Let's try a JS bin instead. It's getting annoying. Let's see if it works here. See, let's run that. Awesome. Okay. So what happened here is just we created a try. So small. We use the try keyword to try to throw a new error. Nothing really. Okay, doesn't really help. Okay, let's use another code. Let's see this one. See if that works. Okay, now we have a function called prompt direction. What happens is we prompt the user, and we can ask them a parameter, a string, and basically we evaluate if they get left, the function would return L. If they write the direction of right, they would get a return value of R. Else, they would throw an invalid direction plus the result. So next, we have a function, look, that would just invoke the other function prompt direction. Okay, let's try to run that. So the browser would ask us a prompt. So which way to go? It just says which way. Let's try L, left. If I tried left, it would go here. You see a house. A house. And then, sorry. So it goes to the try catch. You see, then a house. And because another keyword that we have is the finally keyword, so whether it catches an error or not, it will still execute. So you would have this, thanks for trying the program. Let's see, let's try. Go ahead, good. How can I put this smaller? So we want to try to console.log what? A string, and also the look function. We want to invoke the look function. In the look function, we evaluate another function, which is prompt direction. Okay, and it will evaluate if we get an L, and if we get an L, it returns a string A house. Okay, good. It's part of the syntax. Mm-hmm.
So now so if there is an error,
Mm-hmm. Actually, it's just a variable. Sorry, it's not a. So you can either put this as, let's say, E. That should work actually. Yeah. Okay, let's try to input something else. Say no. So if I input neither left or right, I would get a something went wrong, error, invalid direction, no. In other cases, without the try catch, we would just say error, or even just throw a random different value. That's not helpful for you. So what happened here is the try is console.log, you see, invoke the look, which invoke the prompt direction. That's why we have the prompt. And then I input no. And now it goes here as the question, right? It gets the question which way first. And then next it evaluates the no. And because it's neither left or right, it threw the new error invalid direction plus the result, which is this one. But because we have the try catch, we also get this something went wrong. So in the catch, what happened is it prints this something went wrong plus E, and E is this one. It looks for the throw. Sorry, it's pretty confusing. I know. Mm-hmm. Yep. Okay, let's see. Let's move on last to regex. A regular expression is a sequence of characters that defines a search pattern for text. Okay, it comes from the mathematical concept of regular sets. Basically, in JavaScript, you can use the capital R, reg, and then exp, capital E, and that's a regular expression object. And you would have access to APIs just so you create a regular expression object. Okay. So let's first try to do some light code. And after that, I'll show you another good resource for regex that you can use your practice your regex there. So let's use the first API. It's called the .test. Let's see. Run this one. No syntax error. Oh. Okay, let's dissect first regex. I guess it was better to just put this up now. It's better to put this up now. Okay. In regular expressions, you would start off with a slash. It indicates the start of the regular expression. Okay. Next is you would need the other slash. Don't mind the letter G for now. It indicates the end of the regular expression. Okay. And now inside of it, you can put matches. So in this case, let's say we have a capturing group. We put it in open parentheses. And now let's say the character set that you want to match, you can do A to Z. Also, you can do smaller case A to Z. And next, after the parentheses, you would have a backslash, and W just denotes a word. Okay? The plus means match more than one. So if I remove this one, let's see, it just matches all the capital letters. You can also do this. All the small letters. If you want to put them together, we can put something like this. Just grab this instead. Okay, this one, put it here. And let's say we want to create a binary expression, okay? Binary number expression. So what we do is we just want ones and zeros, right? So we can have something like that, and it would check all the ones and zeros. And it's not highlighted, the other numbers. Okay? And this one, if you put a caret, which means match, match that is not in the character set. Okay? Let's go back to the test API. So basically, the test API, which is first, sorry, let's clear this up. First line, we create a regular expression object. How do we know it's a regular expression object? We do have a backslash, starting with a backslash and ending with a backslash. And if you assign it to a variable, that variable is now a regular expression object. And that's why when we use the not binary, which is a regular expression object, we can have the .test API, and we put the string there. So this just check is if my string, if it's not binary, which is in this case false, and the other one, we check the string, is this not binary? Yes, it's true. Okay. Next is we'll have the dot replace API. Also, regular expressions are good for input data validation, telephone number format, email format, web scraping, okay? So this one, we have the quick brown fox jumps over the lazy dog. If the dog reacted, was it really lazy? And again, we created another variable called regex. We have dog as a regular expression. And then now we do have the G and I. Basically, the G and I is a global match. It means it will find all the matches rather than stopping at the first match, okay? And I just means I would ignore lowercase, uppercase, okay? So the first console.log is p dot replace. This is a string API. And in that string API, you put a regex or a match. Next is you put the string that you want to replace. That's why now you would see the quick brown fox over the lazy ferret. If the ferret reacted, was it really lazy? Okay, let's run that. And now if we try to remove the G, it should only change one. Let's see, let's comment this out first. The quick brown fox jumps over the lazy ferret if the dog reacted. So it did not change the other dog. Okay. The other one is using the replace API with string, and you can find a word and just change another word or character. The quick brown fox jumps over the lazy monkey. If the dog reacted, was it really lazy? So with this one, the problem with this one, if you did not use regex,
I haven't checked it, but there seems to be no way, but there might be a way, I guess, to have it say that, hey, all the dogs change it to monkey. Unlike in regex, because you can pass this G, means everywhere.
change it to monkey. Okay, let's go back here. Let's try to do an email matching. Zoom that in. So let's put a number, say this one, .edu, blah, 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 at c.edu.com, Amazon at google.microsoft. Okay. So let's, with this regex online editor, we're already given the slash, so we don't need to put that. The first thing we want is we create this one. Open brackets, match any character in the set. What do we want? We want a word that's denoted by \W. And what else? Let's say I want a special character to be included as well. Let's say a period. Let's say an underscore. Let's say a plus. Let's say a minus. After that, I also want to match the @sign. Okay. Also, after the @sign, I also want to match another character set, another word, and I want to include also a dot and a minus. Okay. And after that, I also want to include the dot. I escaped it using the slash. And then any letters, A to Z, and capital A to Z. And that, do this. Can do that one. No, that one. Yep. So right now, what happens is it only checks the first letter that matches. So what we want to do is we put, say, a number here, say 3. Because let's say the convention is just .com, .edu. Let's say it's 3-letter. We can now filter strings that, hey, this is not a valid. Hey, these are valid emails. And let's say someone put a bogus email without the @ sign. Let's see, .edu. Doesn't check it. Nope, does not like it. Okay, so regular expression is a very awkward, but it's very useful once you get to learn it. I don't really suggest you go deeper in regex for now. It's not going to be very, very helpful. Okay, let's try to do some muddiest point. Someone asked about regular expressions, and I'll just give you, it asks about backtracking. So in my research, some of the regular expression matches takes longer than usual, and you would encounter some performance or memory problems with that. So there's a bunch of topic called catastrophic backtracking. I'll just include that in the notes to post that for you to read. How often should use used? How often should useStrict be used in regular JS programming? The answer is yes. No need to add in every function body, just at the start of the file. And can you write test code in JavaScript like you can use JUnit testing in Java? Yes, you can. And like JUnit, you also need to download, or import the unit tests themselves. So in JavaScript, there's Mocha and other unit testing. And let's see, any questions? Let's see, let's go to our slides for today. It's less than usual. Let's see. So again, let's try to have the concepts drill down. Bugs, okay. Bugs, a software bug is an error, flaw, failure, or fault in a computer program or system that causes it to produce an incorrect or unexpected result to behave in unintended ways. Okay, kind of know all what bugs are, and people always joke that once you have a bug, just call it a feature and present it to your customer and says, hey, that's part of the feature. Okay, and interestingly, before I think I was looking at the bugs, and I remember, for example, if you know the game Silent Hill, they did have a hard time rendering the buildings around it, and it's like, why is there fog all the time? And that's part of like a bug that became a feature, right? Also, another thing that's not a bug, but it was used in a different way. If you know Grand Theft Auto, again, one of the main purpose there is to really try to play the story, the campaign, but people ended up just playing it for hyperviolence. So not intended, but there was a market, okay? Okay. Again, an error is a mistake, misconception, or misunderstanding on the part of the software developer. For example, a programmer might type a variable name incorrectly, leads to an error. I'll try to connect these things more. So we do have the failure, faults, and error. It's the official IEEE terminology. IEEE is the, what's that again? Institute of Electrical and Electronics Engineers. Most of the time you would see them or read about them online with the journals published. So they do research and put like the standards and whatnot. So again, going back, failure is something that you can see. So let's say a disrupted service. And what caused the failure? Okay, basically it's the fault. There's a bug, there's a defect in code. But what caused the fault? It's a human error. I think this is something wrong. I think. Let's clear that up. Failure. Observable incorrect behavior of a program. Let's say a rocket ship, it blew up. You can see that. and that's a failure. Faults, incorrect code. Error can be typos, can be conceptual. So again, to fix what I've said earlier, I think that was from a wrong resource. If this one has the wrong concept of using a for loop or data type or whatnot, he creates a faulty statement. He doesn't know that he needs to include the 0 or exclude the 0, right? And then now, if the user, and if we're lucky enough, the user didn't really put an input that would break the program, hence no error. But if they input but something that would trigger the fault, it becomes now an error. And again, failure is something you can see. System crash, rocket kaboom. And then debugging, as we all know, is just a way to fix bugs or find bugs. Testing. If the language is not going to do much to help us find mistakes, we'll have to find them the hard way. And by running the program and seeing whether it does the right thing. Okay. Testing was created because doing things hand by hand and again and again is a really bad idea. It's also, they say it's annoying. It also tends to be ineffective since it takes too much time to exhaustively test everything every time you make a change. Unit tests is usually an automated process and performed within the programmer's IDE, which I showed in the code a while ago. So you run unit tests to your code, to your function, to check that any weird user input is covered in your function, and it would not just break the program or throw a weird error. We already talked about the arrange act assert, which is a pattern used for formatting code in unit test method. That is true for most programming languages and teams. Error handling is important because it makes it easier for the end user to use your code, to use it correctly. Again, because if you have good errors, you also have good loggings. And again, you can get a lot of insight from that error, not just 404 or something like that. If you don't handle your errors, your program may crash, you lose all your customers' work, and likely won't know where the bug occurred. Regular patterns, again, are patterns used to match characters, combination in strings, and a sample of common character groups. A small letter D is any digit character. Hey, let's match any digit character. A /W is an alphanumeric character. /S is a white space, and so on and so on. And this is what we've done a while ago with the email matching. Again, we always put a bracket if we want to match a character set. And this one is to add it to another one and match the @ symbol and add another sequence. And the last one would be like, how many matches do we want? How many characters between 2 and 4? And that's it for the lecture. Any questions? Too much, I know. Again, for those who were late, for those who passed the Linux class, again, we try to lessen the load. It's 15 challenges instead of trying to finish everything. Also, the final project, please don't create a new project. It's ill-advised because it might be very time-consuming. Just try to improve your code and make sure you can showcase a proof of concept or this certain function. It doesn't need to be a full working code. It just needs to, as much as possible, you just need to show something. And I think Sam wants it to make it fun. Okay, make sure it's interactive. It's just not this code, I guess. I think because right now we're still doing this ongoing meeting to
flesh out the details. But I would assume, because it's kind of like a science fair, we would allocate, let's say, an hour where people can just move around and just ask, hey. Yes.
This is for week 17.
Yes.
What else? Also, we do have a new attendance taking system. We're trying to do the QR stuff. And Taisu is heading that. What else did I miss? How about for those who haven't finished the Linux Plus exam? Is the 10 challenges too much? Do we want it to be decreased? Are you guys okay with it? Managing? To be honest. Okay, if not, you can send me an email. And if I receive, let's say, more than 2, let's try to tone it down. What else? Concept test. Okay, let's do concept test. Go ahead. Okay, go ahead.
Do you want to